So what do you think of when you see that picture?
An animal.
An animal? What else?
A skunk.
Do you know anything about skunks?
They are disgusting. They're white and black, and the stink that they produce is a defense mechanism.
You might know too much. Okay, so I'm gonna show you a little video that has something to do with what we're gonna talk about. Okay. Did you learn anything new?
That some bombs die without them and they can't survive.
That face that is usually covered by a cloak has finally made an appearance.
Fine, thank you. Okay, so back to our PowerPoint. So we're going to read a couple articles. But what we want to think about and learn about today, like what our goal of reading these articles is to answer this big overarching question that we're going to call our comprehension canopy. So the overall question we want to answer is, what are some traits of organisms or adaptations that help them to survive in their habitat? So we watch that little skunk video. You might already have some answers or some thoughts on some answers to that big question. But in order to read these articles the best we can, I'm going to show you some words that I thought might be challenging. So I want to kind of explain them to you and make sure you understand those words before we read the article. So the first word that might be challenging is camouflage. So you've probably, your dad was in the military. You probably have seen camo that way, right? But we can also talk about it with animals. It doesn't always have to be like people wearing that like like green and gray and brown pattern to hide when they're hunting or when they're in the military. But maybe it's an animal trying to blend in to the environment. So the definition that I want you to think about when you hear that word is blending into the environment. So some examples of how you could use the word: my dad wore camouflage when he went duck hunting today. The squirrel looked camouflaged in that tree. So an example of camouflage is, I couldn't see the grasshopper when it was in the grass because it was camouflaged. What do you think it means in that situation? Like, how is the grasshopper camouflaged?
Because the grasshopper is green and the grass is green.
Yeah, so it blends into the green grass because it looks like the grass. So a non-example, the runner wore a neon vest and lights when he went running at night. Why would you wear a neon vest at night?
So you could see.
Yeah, so you could be seen. So the opposite of blending in, right? Why would an animal want to be camouflaged? Why would they want to blend in?
So they wouldn't get eaten, and so they might be able to get food.
Okay, cool. So do you think you kind of understand the word camouflage? You see it in a passage? Another word I thought might be tricky is predator. You ever heard that word before?
Mm-hmm.
So the definition I gave you is an animal that hunts and kills their food.
An example is a tiger kills the antelope.
Oh, good. Yeah.
So he can get food.
Absolutely. So if we wanted to use that in a sentence, like we wanted to use the word predator, the tiger is a predator to cantaloupe cantaloupe is fruit, right?
Yeah, antelope.
A tiger is a predator to antelope. There we go. Can you think of any words that are related to predator? Do you know what a predator, like the antelope, do you know the word that we would call the antelope?
Prey?
Yeah, so they're like opposites, right?
Yeah,
so it's like
prey and predator.
non-examples. Predator and prey are opposite. What might we call a person that goes and kills food? I kind of used the word right there. Like a hunter.
Yeah,
so a predator is like a hunter.
Mm-hmm.
Okay. A non-example of a predator is vultures only eat animals that are already dead. So they're actually called scavengers.
Mm-hmm.
Do humans have predators? Does anything try to hunt and kill us?
Not necessarily, no. I mean, stuff can kill us,
Mm-hmm.
but
But we wouldn't say that a tiger is like out to, they're not predators to humans. They're not trying to go out and kill us, right? To eat.
they're only defending themselves.
Yeah. Are humans predators?
Yes. They're predators to pretty much anything.
Yeah, that's a good point. And then I have some pictures. So we have a cheetah and gazelle.
Yeah, maybe.
I don't know what that polar bear is eating, but
Polar bear and I think a fish.
oh, a seal.
Oh.
Polar bears eat seals. It's really sad because seals are so cute. And then a tiger.
Tiger is a predator to everything besides humans.
Pretty much. Yeah.
And maybe lions.
Mm-hmm.
Maybe not lions.
Okay, this word I feel like is probably pretty new. Structural adaptation. So it's really 2 words.
Oh, I know what it is.
So it's a physical trait an animal has that helps it to survive. So I gave you these pictures. Like, see how all these beaks are different?
Yeah.
Why do you think they would have different beaks?
Because it's like they eat different stuff, so
Exactly.
it could fit in their mouth or
exactly. So the structural adaptation is the beak. The different beak is adapted for whatever it wants to eat. So some related words: structural, structure, physical. When you think about like a structural adaptation, it's something that's like physically on them, or it's a part of their body. So example, long necks on a giraffe is a structural adaptation. Birds have specifically shaped beaks to help them eat the food that is available to them. That's what we were talking about in that picture. Another example might be these rabbits have big ears.
Mm-hmm.
Why do you think rabbits have big ears?
So they can hear.
Why do you think what do they need to hear?
They need to hear predators.
Look at you using our new word. A non-example is that bears hibernate in the winter, so they need less food to survive. There's nothing on their body, there's nothing physically about them that's helping them if they hibernate. We're going to talk about that example next. I know it's kind of confusing.
I know the word. But
Oh, do you? It's coming.
I know it has adaptation on it at the end.
You're right.
Structural.
Don't think too hard. Let's answer our turn and talk first. Can you think of an example of a structural adaptation that you've seen? Not one that we talked about here.
Dogs have flappy ears. Some point up and some flappy.
Ooh, so why would their ears be different?
Because if their ears are down, it means maybe they're calmer, or it's just a different type of dog.
It's a different type of dog. That's a good point.
Oh, and then the ones that are up, they pretty much look like vampires, but because normally they have.
What would you want to protect if your ears were down like that? Why do you think they might want to protect it?
Because like loud noises.
Or could something get in their ear?
Yeah.
So Layla is like a retriever.
Mm-hmm.
So a lot of retriever type dogs, they swim. So why might they have?
So cover their ears
To keep the water out. And then if they have the tall ears, do you think they go in water a lot? Probably not. So that's a really good, I didn't even think of that.
But if they have longer ears or bigger ears that are up, they can hear better.
Yeah, that's true.
More clear.
So, and what's really cool about dogs is that you can trace them back to like what they originally were used for. Like now our dogs just lay on our couch and they're just like part of our family, but they used to have jobs. So a lot of their like physical attributes Their structural adaptations
Mhm.
are based on what they used to do. Like if you'll look at Layla's paws, they're webbed. They have like they're all connected.
Like, isn't it for running?
What else do they do?
Swimming.
Yeah, they have webbed paws because they swim. So I don't know. Lots of cool structural adaptations on animals. Was that the word you were thinking of?
No. I was thinking of physical, but
Oh. Well, physical is more we're talking about the structural adaptation. Like the structure of your house is like how
it's
it
like
physically
physical.
looks. So behavioral adaptation. Have you heard the word behavior?
It's
Did your
like-
teacher ever write like Carson had really good behavior today?
I mean, no, she hasn't. But because everybody's pretty much the same besides. Well, we're all the same technically. Because we're all lazy. Sometimes.
So behavioral adaptation, a definition might be something an animal does to help it survive. Related words, behavioral, behavior, habits, personality. Those are all like words you can think about with behavioral adaptation.
So learning to walk is a behavioral adaptation. Or structural.
What do you think?
I think it would be a behavioral because you learn it. And structural, it's already there.
It's a good point. I don't know. That's something we'd have to think about a little more. So an example of a behavioral adaptation might be a bear hibernating. And a non-example is the shape of the beaks. Do humans have behavioral adaptations?
Mm-hmm.
What do you think? Like what?
Maybe learn to walk, but sleep, get up, and we have to eat food. But I was gonna say sleep and walk.
What's different about how we eat food or like maybe where we get food now?
Then the older times.
Yeah.
The older times you actually had to kill it
Right.
with your bare hands or something.
Right. And now what do we usually do?
You just go to the store.
We go to the grocery store. Why do you think we adapted that behavior?
Because it was harder to just go out and get like.
He just wants to be involved.
Like you actually had to go get your food, and instead of now you just have to go to the store and get your food.
So maybe we've like learned a smarter way to do it, or we use less energy. All those kinds of things. I had another picture on here of the squirrel has like it makes a little underground burrow.
For the winter.
Mm-hmm. All right. So we talked about a bunch of new words. They're not that critical. But we're going to read 2 different articles. Do you remember what our question is that we're trying to answer?
What traits or adaptations, something.
What are some traits of organisms that help them survive in their habitat? Okay.
Well, I know some. I know one for. Skunks.
Yeah.
They spray like stuff on them.
Yeah, we saw that in our first, just in like our little introduction video, right?
Yup.
So there's at a couple points, like I will stop us while we're reading. Do you want to read out loud to me?
Oh, sure.
I would appreciate it. I would appreciate it more if my computer would log us in.
I mean, it might not.
What are we going to do if it doesn't?
I don't know.
I don't know.
Maybe click on the next
Oh.
Hopefully it works. Clever.
Do you use Clever at school?
Yeah, sometimes. You have to do it for like this online reading thingy. You have to sign in to actually get
For your reading stuff?
sometimes. So.
What reading program do you use? Sora?
Sora and Epic.
We have Epic.
Sora is like where you check out books. It's like an online library, pretty much.
Oh.
Unlike where Epic, where you just get it. You can read the book automatically. You actually have to check out books to read them.
On the Sora?
Mm-hmm.
Hmm. So like not everybody can read the same book at once?
No one.
But like Epic, you can all be reading the same book.
But I think Sora has more books than Epic does.
All right.
I don't know.
Maybe. Safe and sound and smelly. Stinking helps some animals survive. You want to read?
I don't know what that first word is.
Deodorant.
Perfume, soapy showers.
Hold on, time out. Do you know what deodorant is?
Yeah.
Okay.
Most humans make a big effort to smell good, but out in the wild, it can pay to be stinky. You probably already know that skunks occasionally spray humans and their pets. The chemical compounds that shoot out from their behinds have a horrible smell. The stink burns eyes and can make people throw up. And that's the point. A skunk sprays only when it thinks danger is nearby. It wants to stop predators in their tracks. This superpowered stink is the result of natural selections, which is how animals evolve or change over time. A creature that can defend against predators is more likely to survive and have babies. That means traits that keep a critter safe are more likely to be passed on from generations to generations. Some animals relied on strength and speed. They became stronger and faster over the course of many, many years. Others got really good at hiding and developing camouflage. They changed the way they looked to match their surroundings. And while it might not sound glamorous, some animals evolved to smell bad.
Pause. So, what do skunks do to scare away predators?
They shoot out stuff from the behinds.
What about the stuff?
And it's like a chemical, and it makes people throw up and burn their eyes.
Because it does what?
It stinks.
All right. Skunks are not the only stinkers.
Skunks are most famous stink sprayers, but they're not alone. Millipedes are worms that
they're worm-like. So it means they're kind of like worms.
Bugs with hundreds of legs. They spray a nasty liquid out of their bodies when disturbed.
Bombardier
beetles shoot out a stinky spray that can reach boiling temperatures as if the smell wasn't bad enough.
So they can reach boiling temperatures? So what does that mean?
Like hot temperatures.
So they spray something that's stinky and hot?
Yeah,
that's gross. Okay.
There are other ways animals scare off a predator with terrible smells, vultures survive on the rotten remains of dead animals. When vultures sense danger, they will spew chunks of puke. Ew.
That was gross.
This makes them lighter so they can fly away more quickly. The smell of the throw up, rotten food is usually enough, though, to make anyone back off. Possums are most famous for playing dead until the predator loses interest. They make a nasty mucus that comes out of their bottoms, so they smell dead too. Ew. They stink.
So all these animals put out bad smells or make bad smells. Why do they want to smell bad? What's the point?
Because they're smaller than most animals and they still have predators. They call them.
Oh, so if they smell bad, then what? The predators will do what?
So run away.
Yeah, they'll leave them alone.
Because it stinks.
Yeah, nobody wants to be around a stinky thing.
Not so stinky to some animals. But not every stink is designed to keep bad things at bay. Some eye-watering odors
Good.
are meant to attract attention. Hyenas spray a stinky butter with their bottoms to communicate with the other. What?
That sounds
Hyenas.
funny. Hyenas spread a stinky butter with their bottoms to communicate with other hyenas.
How? Male musk.
Well, hold on. That's an important question.
What?
I know it's kind of gross, but so it comes out of their butt
Yeah.
and they just like spread it around on the ground.
But how
Well, what would you
communicate?
well, think about it? How would that communicate with someone?
That they're there?
Right. So they want someone to know that they're there. Okay. Male musk oxen produce musk.
An oil-like liquid that covers their fur. In case you couldn't guess, the musk is very stinky. It is used to mark territory during mating seasons. Plants get stinky too. The huge corpse flower, named after the word for a dead body, is known for smelling like rotten meat. The flower is hoping to attract nearby beetles in search of dinner. Those bugs do the work of pollinating the corpse flower. The terrible smell is a key to the plant's survival. I don't know how that is, but okay.
All right. Well, let's think that one through. So the plant smells like burning or like rotting meat.
Mm-hmm.
What does it attract?
It attracts beetles.
So the beetles obviously like the smell, right?
Mm-hmm.
So when the beetles come, what do? Do you know how plants like germinate? Like how plants like make other plants?
Yeah.
Like pollen goes from one plant to a next.
Yeah, and the seeds and spores go off.
Yeah. So if the beetle comes onto the plant, it's going to get pollen on it, right?
Mm-hmm.
And then what's the beetle going to do when it realizes there's no meat here to eat?
It's gonna leave.
It's going to leave. And what does it take with them?
Pollen.
Yeah. So it pollinates, it spreads the pollen for this plant. All because of what?
The dead meat.
Because it stank. Those bugs do the work of pollinating. The terrible smell is the key to the plant's survival. So are smells ever used? So we learned about skunks make smells to keep people away, to keep predators away.
And then hyenas spray butter and to like communicate.
Right. So are smells used to attract animals?
Kind of thing.
The butter, right?
Mm-hmm.
Because it wants the other hyenas to know it's there and like to come or whatever.
Mm-hmm.
So overall, tell me about how animals use smells.
They use smells. Oh.
Excuse me.
They use it to attract animals. They use it to make them go away, and they make it to pollinate.
Okay, cool. So lots of different uses for different smells, right? Why do different animals use the smells differently?
Because it's how they do it. So one would do that, and they made it to where they would know. So I think it's a behavioral adaptation, or I really don't know. Forgot.
So it's some sort of adaptation though, right?
Yeah.
Whether it's behavioral or structural, we can talk about that separately.
Yeah.
But they've adapted to use smells for what they need.
Mhm.
Good. All right. Do you remember that overall question that we talked about at the beginning?
Yep.
What are some traits or adaptations that help animals to survive?
Stink,
Right?
and that stuff.
Yeah. All right. I got another passage for us to read. Still talking about how animals use adaptations. All right. Our title is just adaptation. Actually, I don't think that's the one we're supposed to be reading. Oh, yeah. To that one. Okay. So adaptation.
And the adaptation is a
Type of
mutation.
Yeah.
Or change in the organism genes.
Good.
Genes can be throughout as instructions. They are passed down from parent to child. They shape how living things look and behave. An adaptation helps an organism, such as a plant or animal, survives in its environment. The mutation is passed from one generation to the next. As more and more organisms inherit the mutation, it becomes part of a species. The mutation has become an adaptation.
So what tells an organism how to look and behave?
Its parents.
And specifically, what do parents pass on to their offspring? What was that word?
Mutation.
Mutation. What are the instructions for those mutations called?
Genes.
Yep. So let me ask the question again. What tells an organism how to behave and act?
The genes.
Very good.
Or the parents pass on the genes.
Yep. All right. So structural and behavioral adaptations.
An adaptation can be structural, meaning it's physical parts of the organisms. And adaptation can also be behavioral, affecting the way the organism acts. An example of a structural adaptation is the way some plants have adapted to life in the desert. Deserts are dry, hot places. Plants called succulents have found a unique way to survive there. They have adapted to the climate by storing water in their thick stems and leaves. Animals migrate. Migration is an example of a behavioral adaptation. Gray whales migrate thousands of miles every year. They swim from the cold Arctic oceans to the warm waters of the coast of Mexico. Gray whales' calves are born in the warm water. Later, they travel in groups to the nutrient-rich waters of the Arctic.
What is a gray whale calf?
It's like a calf that's gray. I guess.
So the gray whale,
Oh, it's like,
the babies of the gray whale.
yeah, it's called
Calves.
calves.
Yeah. So gray whale calves, the babies are born in the warm water. Okay. Do this paragraph.
Some adaptations are called
Oh, we were going to skip that. Sorry, we don't need that. Okay. So ignore that. What are two types of adaptations?
structural and what's it called? Keep forgetting it.
Your teacher writes
Behavior.
about your behavior. Good. Can you tell me the difference?
Behavioral is like it's like passed down or something like that. Or no, it's
So
their body is structural.
Yep.
And then behavioral is like how they act.
Perfect. That's exactly right. Okay. So we're going to skip that one.
Habitats.
Yep. Let's start there.
Adaptations usually develop in response to a change in an organism's habitat. The English peppered moth is a famous example. Before the 1800s, the most common type of moth was a cream-colored with dark spots. Few peppered moths display mutations of being gray or black. As the rise of factories change the environment, the appearance of peppered moth changed. The darker colored moths became less rare. In fact, they began to thrive in smoky cities. Their soot color blend into the trees stained by industrial pollination.
Hold on.
Pollution. Birds cannot see the dark moths, so they ate the ice cream colored moths instead. Or
Just cream color.
Cream. Same thing.
Okay. What happened? So pollution increased. What does that mean? What does that look like?
Like pollution? It means like pollution is like trash and stuff.
Okay.
And
specifically here, we're talking about like pollution in the air. And it like gets on the trees and it gets on the buildings. So what do you imagine is happening to the trees and the buildings when the pollution is increasing? They're getting darker. Okay, very good. So pollution increases. What happens to the moths because the pollution increases?
They're less rare than they were because they would stick out.
Which ones stick out?
What's it called? The soot thingy. Or the darker colored moths.
The darker colored moths stick out in the pollution?
Or not in the pollution, before the pollution.
Okay.
And then after the pollution, the other ones stood out.
The cream colored ones stick out, right? Can you picture that? Like if you have dirt everywhere, if you have this white moth, like cream colored is like white, basically.
Yeah.
Like that is cream colored.
Yeah. I would see it.
So you would see it in the soot, right? In the pollution. So Now that there's pollution, what is more common of a color in moths?
Like black or gray.
Yeah, like these peppered ones?
Mm-hmm.
Yeah. So what kind of adaptation would that be? Is it their body that helps them, or is it their behavior? So if it's their body, what kind of adaptation do we call? Your arm is like a structure.
Structural.
So structural adaptations are helping these. Good. Okay. So we finished that. All right. We're going to read I'll read the last paragraph to you.
Right.
Co-adaptation. Organisms sometimes adapt to and with other organisms. This is called co-adaptation. Certain flowers have adapted their pollen to appeal to the hummingbird's tastes. Hummingbirds have adapted long, thin beaks to collect the pollen from certain flowers. In this relationship, the hummingbird gets food and the plant's pollen gets distributed. The co-adaptation helps both organisms. Mimicry is another type of co-adaptation. With mimicry, one organism has adapted to resemble another. For example, the harmless king snake has developed a color pattern that resembles the deadly coral snake. This mimicry keeps predators away from the king snake. I thought there was another paragraph. We skipped this, didn't we? All right. I'd rather talk about this. So,
co-adaptation is pretty much where you mimic something to where other people or other animals wouldn't kill you because they think you're poisonous or a bigger species than you actually are.
Well, that one was specifically called mimicry, which that's part of co-adaptation. But
and then
what was
other part is to where looks like the beaks of the hummingbird are long so they can get pollen, and then
it has a long beak. What kind of adaptation is that?
It's a structure.
Very good. You're gonna remember that word. Yeah, you are. So, and then how did the flower adapt though?
The flower put out pollen, appealed. So it appealed,
So if Chick-fil-A appeals to you,
it's good.
You like it, right? So the hummingbird likes the pollen and wants to come to that flower now. Good. Okay. All right. What do you think we're going to go back to at the very end?
The word.
What's that big question I was asking you?
What is an organism or something?
What are some examples of adaptations that help an animal to survive in their habitat? So if I was teaching this to a whole class of kids, I would probably give them a piece of paper. No, I would give them a piece of paper and ask them to all write out their response. Mm-hmm. Do you want to write your response or do you want to tell me your response?
Tell.
Okay.
Because I can't write very good.
Oh, hush. Your hand hurts? Oh, my. Okay, so tell me about some adaptations that help animals to survive. What's the most obvious one we talked about?
It's structural adaptations and behavioral adaptations.
Okay, so we talked about those two types of adaptations. But right now, I really just want you to give me examples.
Oh, so so technically this would be a structural adaptation.
Okay.
They make the king cobra or snake looks like a deadly coral snake, so they wouldn't, like the other stuff wouldn't intervene with it.
Okay.
So
So
that
it
would
looks
be
like one of the.
that would be a structural adaptation because
Okay.
it's on their body.
Okay. What else? What were some other ones we learned about?
The dogs. The dogs where they had ears sticking up and flapping.
Read about or tell me about some ones that were in our reading that we read about in one of those two passages.
The hummingbird where it has a long beak, and then the flower which it attracts its.
Okay.
So it
Go back to the very beginning, the very first article we read about skunks.
So the skunks make it go away.
They do what to make things go away?
They shoot out an odor.
Tell me about an animal that used smell to communicate.
The hyena.
What does it do?
It puts his butter on the ground that comes out of the behind.
Don't turn that on yet. When we're done, we're almost done. Okay. And then let's see. Can you think of one more adaptation in
the plant, and it makes the beetles get in. It tastes like, or it smells like dead meat. And when they don't figure out that there's no dead meat there, then they have pollen on them, and they go to another flower.
Awesome. I think you learned a lot about adaptations today, don't you?
Yeah.